Hey y'all, in this video we're going to talk about midsegments of triangles and trapezoids and see what's so special about them. So first let's review what the midsegments are of a triangle. Remember, a midsegment is a line segment connecting the midpoints of two sides of a triangle. So midpoint, midpoint, connection, midsegment. Of a trapezoid, it's more specific. It's a line segment connecting the midpoints of two sides that are not the bases. So we can't look at the bases. The midsegment connects the midpoints of these two sides, the sides that are not parallel. So this is the midsegment. So the question now is, what can we show as true about midsegments? So first, what we're going to do is we're going to take a triangle, any triangle, and construct all three midsegments by connecting the three midpoints. And you'll notice I have created 1, 2, 3, 4 triangles. And I want to know what's up with these triangles. Now, all of these markings here, you kind of suspect that there's going to be some congruent triangles in here, but I have a 1 and a 2, a 1 and a 3, and a 2 and a 3, so I don't have congruent sides yet. So I'm going to use my old friend patty paper, and I'm going to make an exact replica of this triangle, and I'm going to see what's happened. So I'm going to look at specifically this triangle here, and I'm going to see if it's congruent. So I got to move Grogu and his little chicken away. So if I take this triangle, think about this triangle, and I move it up here to this top triangle, oh hey look, they're congruent. And if I move it down here to this triangle, oh hey look, they're congruent. And if I do a little rotation, oh, surprise, surprise, that middle triangle is also congruent. So what I have here when I connect the midsegments of any triangle is that I create 4 congruent triangles. So what I'm going to do is I'm going to go ahead and add the tick marks they're missing. So I know this is 1 and a 3, so that's a 2. 1, 2, that means that's a 3. 2 and a 3, that means that's a 1. So all 4 of these triangles are congruent. Okay, so fancy. What does that give me? Well, it gives me a bunch of corresponding parts being congruent. So let's specifically look at this triangle that has a 1, 2, 3 and a 1, 2, 3. They're oriented the same way, right? So first side, second side, third side, first, second, third, right? And so that means I know that this angle here that's made by the 2 and the 3, shrunk, is congruent to this angle here made by the 2 and the 3, shrunk, right? So those two angles are congruent. Oh, hey, wait a minute. If I think of this side of the triangle as a transversal, and these two lines here, this midsegment and this thing here, this side of the triangle, as being two lines, the fact that these two angles are corresponding and congruent means that this midsegment has to be parallel to that base. So I can draw parallel markings there and there. And similarly, I can look at the other midsegments and I can come to the same conclusion. I'll get corresponding angles. This means that midsegments are parallel to a third side of the triangle. And you'll also notice that this midsegment is half the length of the side it's parallel to. So this has the length of 1 unit, a copy, so this is twice as long as that. So this gives me my 2 conjectures for triangle midsegments. The first one, C42, is the 3 midsegment conjecture, also known as the midsegment triangle, because it's about the triangle formed by connecting the midsegments. It says the 3 midsegments of a triangle divide the triangle into 4 congruent triangles, and we showed that with the patty paper. And then C43 is the fancy one, and this is the one that you're going to use most often. It's the triangle midsegment conjecture. It says that a midsegment of a triangle is parallel to the third side and is half the length of the third side. So what's special about this trapezoid midsegment? Remember, for a trapezoid, there's only one because it has to connect the non-parallel sides, right? And so I have my trapezoid here. It's not marked as a trapezoid though, so. And I have its midsegment, drawn in with the midpoints labeled by those two sides being congruent. And I want to know what's special about the midsegment. You can kind of suspect what's going on by the drawing, because I actually tried to make a good drawing, so it's to scale and actually a parallelogram, kind of. So you can kind of see what's going on, but look, we're going to use our trusty patty paper again. And I've numbered the angles 1, 2, 3, 4. Okay, so if I have angle 3 here, see what happens when I move angle 3 down to this corner. Oh, wait, what? Angle 3 is congruent to angle 4. And oh my gosh, what does that mean? That means that I have this congruent to that. And just like the midsegment of a triangle, if I think of this as a transversal and these as two lines, right? The midsegment and that base being two sides, or two lines. Those two lines are cut by this transversal. And because those are corresponding angles and they are congruent, I have to know that these two lines are parallel, right? And so this base and that midsegment are parallel. And because the two bases are parallel, that means the midsegment is also parallel to the top base. So I've got sets of 3 parallel lines. And so that's one of the things that's super special about the midsegment of a trapezoid. And there's one more thing. So for this last property, I'm going to use this trapezoid here with base 1, base 2, and the midsegment labeled. And I'm going to go through and do this construction, right? I'm going to find the sum of B1 and B2, and I'm going to find the midpoint of that sum. While I'm reviewing how to perform this set of constructions on patty paper, I want you to try to think and see if you can remember what this construction actually gives us mathematically speaking. So if I want to construct with the patty paper, I draw a ray that is definitely going to be longer than my sum. And I put the endpoint of the ray on that line segment, and I copy the other endpoint. And then at this endpoint, I connect on the second side that I'm going to copy on for my sum. And then with patty paper, I have my two endpoints. And so if I want to find the midpoint, all I have to do is fold the paper in half, and I've marked the midpoint of the sum B1 plus B2 with that little dot right there. Okay, and I'm going to see what goes on when I move that line segment over to my midsegment of my trapezoid. And what is that? What? It looks like half of that sum of the bases is the length of my midsegment. And so if you remember what that construction creates, it creates the average, right? This constructs the average of the bases. So that means M is equal to 1/2 of base 1 plus base 2. And that's my other special property of midsegments. And we're going to call that C44, trapezoid midsegment conjecture. It says the midsegment of a trapezoid is parallel to the bases and is equal in length to the average length of the two bases. Now I have a special task for you. It's a simple one. It's a thought experiment. And I want you to think about what happens when one of the bases of the trapezoids shrinks down to a single point. Okay, so think about what shape that creates. And the question is, does the conjecture C44, those properties, does it still hold with that new figure that's been created?